Objective 2 in part 2 is moving into solving quadratic functions using the square root method. So in Objective 1 we practice reducing radicals or reducing square roots or simplifying the square roots. And so that skill is very necessary to master before you can enter into this process. From this video on and moving into other videos, we're going to be talking about different ways to solve quadratic functions. This whole Module 3 is about solving quadratic functions. We've practiced solving by factoring, whether it's using the MACAD T-chart, or finding the greatest common factor, or factoring difference of squares. And so now we're going to practice solving these functions using the square root method. The first thing to consider, and we've already talked about this in other videos, but if you take the square root of a number, that's what this is saying right here. If you take the square root of a number, it will have exactly two solutions. Because if you remember, the square root of any perfect square, let's say the square root of 25 equals 5. But it has to be plus and minus 5. Because remember, the positive version of 5 squared, or 5 times 5 equals 25, and also the negative version of 5 squared equals 25. That's why we have two solutions every time we take the square root of a number. Now, the first, I'm going to actually show you 1, 2, 3, 4, 5 different ways that you'll see these on an exam or on a quiz. And I'm going to show you how I would solve all 5 of these, just so you can be prepared to practice all the formats on your own. The first thing that clues me, though, that I can use the square root method, because again, on the test, all I'm trying to provide you with are just different tactics or different strategies or tools you can use to solve these things. The first thing I would look for is that, for one, it's an equation, so there's an equal sign, but also, more importantly, there isn't a b term. If you notice, there's the quadratic a term, and then there's a c term. Sometimes they'll be on the same side of the equation, so it would be x squared minus 9 equals 0, that type of thing, and you could move it over to the other side of the equation. Sometimes they'll just be written like this, to where it's already equaling a number. But those are the biggest clues, is that, so I'm going to write that. The clue to look for this, please write this down, is that there's no b term. Meaning there's no linear term, or no term of x. No linear x term. In the standard form, ax squared plus bx plus c, the only time you can use this solving by square root method is when this term isn't present, all right? And that actually showed up as well in the difference of squares factoring. It didn't have a b term either, but that's a little bit different. Both of them had to be perfect squares. And in this case, sometimes they won't be perfect squares. So again, this is just a strategy you can use to solve quadratics. Well, let's get started. I'm going to model number 1. The first thing I would notice, again, is the equal sign, and also that there's no b term. So that tells me that I could use this square root method if I wanted to. First step, then, always, is to, please write these down, isolate the variable. Meaning, getting x, or whatever variable it is, by itself. In number 1, it is already by itself. So, let me switch this up. Isolate the quadratic variable. So, isolating the quadratic variable. X squared is already by itself. So, I've already done that step, or that step's already done. So, that's check for this one. Second step, then, is to take the square root. To cancel out power. To cancel out the power. So again, this power here, if I take the square root, And whatever I do to one side, I have to do to the other side. If I take the square root of both sides, this radical and that power cancel each other out. So I would be left with x equals, and then whenever I take the square root, 9 is a perfect square, so my final answer would be plus or minus 3. And then I'm done. If it is simple like this, which this one is, then you've reached your final answer right here. I'm going to show you different forms that you'll see in different pieces of this, and it won't be just as simple as that. Let's move on to number 2, example 2. If I was going to do number 2, it's the same thing. I would take the first step of isolating the variable, the quadratic variable. It's already done for me. So then I'll move to step 2, take the square root to cancel out the power. Whatever I do to one side, I have to do to the other. Now, the only difference in number 2, hopefully you notice that 5 is not a perfect square. So these cancel out. I'm left with x equals plus and minus. If that's the case, then if it's not a perfect square, I have to consider breaking it down to reduce it. But the only factors of 5 are 5 and 1. And there's no pairs there, if you remember from simplifying radicals from the video before. So because there's no pairs, I just leave it as radical 5. It stays trapped in the radical. And I'm done there. So if you ever encounter one that's not a perfect square, your first thought should be, I need to reduce this or simplify it by doing the factor tree and looking for pairs. That should always be your first thought, after you check to see if it's a perfect square or not. Alright, finally, let's look at the other forms you see. Now, at times there will be